Okay, hi you guys. This is example 4 from the extra practice SHRATEY problems that are linked in your unit calendar. This is the classwork grade for today. Please pause the video if you haven't worked it yet. I want you to try it on your own first and then check it with the key or watch this video, okay? Don't forget your test is next week. It's on Tuesday for Tuesday, Thursday kids, Wednesday for Monday, Wednesday, Friday kids, and Monday is a school holiday, all right? So the S step for SHRATEY is to factor if possible and then simplify if possible. And so when we look over here at this problem, 2x squared minus 4x plus 2 over x squared minus 9, there's actually several different factoring methods that we can use here. Well, several is a strong word. There's a few. If you notice in this top, in the numerator, first thing we want to do is a GCF because they all have a 2 in common, all right? And then once we do the GCF, we'll still have 3 terms left. Whenever you have 3 terms, you try that cross method, right? What multiplies to AC and adds to B. And then you can either do swing method after that or grouping, whichever you like better. And then on the bottom, we have 2 perfect squares that are being subtracted. So that's difference of 2 squares. So here's our game plan. We're going to do GCF and cross method in the numerator, and then difference of 2 squares in the denominator. All right. So coming over here, I'm going to do GCF on the numerator first. So that's pulling out the 2, leaving me x squared minus 2x plus 1. And then difference of 2 squares on the bottom, you square root each of these terms. So that gives me x here and 3 here. And then you make factors with it by doing a plus version and a minus version with those 2 terms. So x minus 3, x plus 3. Now we're not completely finished because this piece right here can be factored further using the cross method. So I'm going to make my cross. What multiplies to AC and adds to B So AC, there's a 1 in the A position, C is 1, so AC is 1 times 1, or just positive 1. The B value is negative 2, and we want 2 numbers that multiply to 1 and add to negative 2. So that's negative 1 and negative 1. And so what this gives me is, just for this trinomial, it gives me x minus 1 times x minus 1, or we can write that as x minus 1 squared over x minus 3, x plus 3. And none of the factors on top or bottom are the same, so we're done there for the S step. A quick bad math alert. Remember, just because there's an x on top and an x on bottom here, for example, you can't cancel those out. You can only cancel factors, which are things that are being multiplied. You can't cancel individual things that are being added or subtracted to other things. So the 2 could have been canceled with something. This grouping x minus 1 can be canceled, or x minus 3 or x plus 3. But individual terms inside the parentheses, they can't be canceled. You can only cancel stuff that's being multiplied. And then the H step on your SHRATEY sheet is for holes that are created when a factor cancels up here in the S step, but no factors canceled. So this is not applicable because no factors canceled. Okay. Now R stands for roots. That's your x-intercepts. And the roots are when you set the top of your factored form, when you set the top equal to 0. So let's do that now. I'm going to divide by 2. That gives me x minus 1 squared equals 0. Square root both sides, x minus 1 equals 0. Add 1 to both sides, x equals 1. So I have a root at 1, 0, but it's a double root, right? Because another way of thinking about this, if you didn't write x minus 1 squared in S step, maybe you had it written out as two individual factors, x minus 1 times x minus 1, then you would have just set those equal to 0 and solved them, and you would have gotten the same thing. This is a double root, right? The square means that it's going to bounce there. So we really have 1, 0 as two solutions, right? Or a double root. Okay, so and we wrote it as a point, right? X is 1 when y is 0. This is your x-intercept, so the y value is going to be 0. A stands for asymptotes, specifically the vertical ones. So in R, we set the top of our fraction equal to 0. For A, we set the bottom equal to 0. And that was x minus 3, x plus 3. Break those up. Set them equal to 0 individually and solve them. And we get x equals 3 and x equals negative 3. Now these are lines, so you write the equation of the line just the way they already are, x equals 3 and x equals negative 3. Someone's at my door. So those are already equations of the lines, and I'm going to go start graphing this on my graph. So I've got 1, 0, which is going to go here. That's on the x-axis. And then x equals 3 and x equals negative 3. Remember, those are imaginary lines. They're just boundary. They determine the behavior of the graph, but we're not going to put a solid line because they're not actually part of the graph. All right, so there we have some stuff. So those are vertical asymptotes. And T stands for, remember, tangent over together. So tangent meaning, and so tangent's in the numerator. Numerator is root information. So we're looking to see if any of the roots are going to have a bounce, right? If it's going to be tangent there. And then for together, we're talking about on either side of the asymptote, as x comes in from the left and x comes in from the right, what's the behavior of the graph going to do there? This is coming together when they're both going the same direction on either side. If one of these was going the other way, like if one was going down on the left and up on the right, that's not together, right? So that's apart. So that's what the T step of your SHRATEY cheat sheet is for, is to determine that behavior. And so in this step, we're really just writing the information down. We're not actually going to go graph it just yet because we have to figure out later how it all plays together. So what we're going to look at to decide if it's tangent at a root is, was the corresponding factor 4 or 0, was it squared? And it absolutely was, right? It repeated twice. So it is going to bounce at the point 1, 0. And that was our only root, so we don't have to talk about it anymore. If it had not been squared, we would have said it's going to cross through at 1, 0. And then now we look at each of our asymptotes individually. And were either of the factors that went with that asymptote, like for example, x equals 3, its corresponding factor form is x minus 3. It's not squared, so it's not together at x equals 3. It's going to go apart or away or be opposite. And then at x equals negative 3, its corresponding factor was x plus 3. Again, not squared, so not together. It's going to go apart. And this is information we're going to come back to in a little bit. And E was for end behavior. So when you go to your SHRATEY sheet and talk about end behavior, it says to look at the leading terms. And don't forget what I had you write down on there was, you want to look at the leading terms in the original problem before you factored and simplified. And so that's these terms right here. And you're going to keep them in fraction form. and then look at it. Okay, so 2x squared over x squared. What you're looking at here, you have two options. This is either going to be a balanced situation or bottom heavy. And the way you determine that is you look at these exponents. They're equal. So this is balanced. And E being for end behavior means we're trying to find the horizontal asymptote, because that's what determines how the behavior of the graph looks on the ends at positive and negative infinity. And on your SHRATEY cheat sheet, it says if you determine it's a balanced situation, like now, what you do is you simplify the fraction, so the x squareds cancel, leaving me 2. And whatever number you get here, and it could be a fraction sometimes, it could have been 2 over 3, that's not a problem. Whatever you get here is the value of your horizontal asymptote. And then you go plug that into your graph, okay? Y equals 2. And even though I'm drawing this all the way across and through the middle of my graph, remember that it really only determines the behavior at the ends. It's okay if your graph crosses in the middle somewhere. But as it goes out to infinity, it's going to be pulling your graph down towards it, depending if it's above or below. It'll be pulling it towards itself, towards the ends. And just as an aside, if this had been a bottom-heavy situation, so this is just a separate example. Let's say we had this, 2x squared over x cubed bottom-heavy. You don't simplify, it's just automatically going to be y equals 0 for your horizontal asymptote, okay? And that's a side example, right? That's not part of this problem. And then the last thing is the y-intercept. This is where the graph crosses the y-axis. And notice everywhere on the y-axis, x is 0. So algebraically, what that means is you can just plug 0 in for all the x's. You're just going to substitute it in there. You can use either the original problem or the factored form. I like the original problem better, so that's what I'm going to do. 2 times 0 squared minus 4 times 0 plus 2 over 0 squared minus 9. Now, everywhere you see a 0, that term's going to cancel out, right? 0 squared is 0 times 2 is 0. 4 times 0, 0. 0 squared, 0. So this leaves me 2 over negative 9, which means my y-intercept when x is 0, y is negative 2 ninths. Okay, so I'm just going to estimate that to be about right here. And now here's where we start piecing everything together, okay? And remember I told y'all, every problem starts a little bit differently. Here's how I'm lucky on this problem. I'm lucky because there are 2 points in the same section of the graph. So this already pretty much determines the behavior for this middle part. If I did not have a second point there, I could find one for myself by making a test point. I could take, any x value, like the 2 or the negative 1, plug it in, do the math, and I'd have a test point. Okay, so anytime you're not sure how to get started, find a test point and get started from there. And here's how I can use these two to get started. I know from my t-step, from tangent, that it's going to bounce at that root of 1, 0. Now, there are 2 options for bouncing. It can bounce up or it can bounce down. Because I have the second point, I know it's going to bounce down. I also know that this middle piece is going to either look like x cubed or x squared. So because it bounces, it's going to be an x squared. So that's enough information for me to fill this in right here like this. Okay. And so this is how I get started on this particular graph. I started here. And then remember, we talked about the ends are going to be those L-shaped curves. They're going to be this shape. So these shapes always for the ends, curved, and the middle shape's always either going to look like x cubed or x squared somehow. Maybe reflected, like this one's reflected down, but it's still x squared shape. So to figure out the left and right pieces, I know it's going to be like this somehow.